Good morning, everybody. Okay. Can we start with a strength guy from Asia to talk about strength things? No. Okay. Today, I would like to present in our work in 3 parts: introduction, the methods, and derivation and conclusion. First, I would like to introduce what is norms. How many people here know Japanese or Chinese? No one? No, he's Japanese. Okay, norm is a family is the same. Maybe because it's based on Chinese character, and it was used in Vietnam from 10th century to 20th centuries. But now the Vietnamese use the alphabet based on the Roman alphabet. It's very simple to study. So now the Vietnamese don't use norm anymore. And here is an example of the norm test. In the second line, there are the current Vietnamese. And we can see here, norm, they have 2 types of norms. One is the borrowed character from China. It's the classical or traditional Chinese. And the native norm, the invented character. In small case, the invented character. The invented character is a combination of a sound element and meaning element. So the invented character is more complex than the original. And how is it today? As I said, it now is not used in Vietnam now, and it's completely replaced by the current Vietnamese. Do you know the population of Vietnam? 90 millions. But now there's only 100 scholars on the world can read the character. And recent years we have started to collect the norm documents, about 30,000, only 30,000, not million as in Europe. And but just only less than 10% was translated to the current Vietnamese. So most of 1,000 years history were not assessed to the current to the Vietnamese. And this is a project between the National Library of Vietnam and the Vietnamese Norm Foundation. They have a scan about 5,000 documents, the most valuable ones, and providing online access to the 2,000 documents. And there are some example of these documents. There's many layouts, and they are maybe either printed and they are handwritten documents. So when I start to study the master course, and I have have a research what's the object of our research, and 4 years ago I began to know norm, and because this serious situation, and there are available material for me to do research, so I started this project, this works 4 years ago. So what we aim at, because there are not many people can read norms, so we want to construct a support system for designing norm documents. We will provide a set of document image processing, character recognition system, and a user interface for verification. And especially, I want to sorry. Okay, and especially I want to lay a foundation, a background for the future research and development on this kind of documents. And this is the overview of our system. There's four modules. The first is the by layout analysis. Will binarize the document and segment into the character, and at the same time with the recognition, we will collect the patterns because there's no data set for norm now. There's no data set, there's no data, there's no anything for norms. So we have to start from the beginning, and it's necessary to collect patterns, the character patterns. And the third is the character recognition. And we put the parallel analysis and character recognition into the practice of document and digitization. And from now, I will explain more detail about the modules. First, in parallel analysis, there are three processing, pre-processing, binarization, and character segmentation. We have already implemented this kind of processing. And this is the reason of this processing. We detect and blur the red comment. I don't understand what it means, but we have to remove it before it will be noise in the binarization process. Blur, and we have to delete the black margin and binarize. And then we have to remove some line. There will be a border line in this kind of documents, and some noise, and segment into character. Now we use only the segmentation. It's not you because there's no OCR for norm, so it's not recognized by segmentation, not yet. So maybe the accuracy of this segmentation is not high, about 80%. As I said, we have no data set for norm. So from the beginning, we generate the database of artificial character patterns from phone character patterns, and we have a view on apply recognition engine. And because there are many characters, there are many categories of characters, so we have to improve the accuracy and the speed of the recognition engine. Okay. In order to generate artificial, we use the distortion models and to produce the artificial character pattern from 27 CG KV phones. It means Chinese, Japanese, Korean, Vietnamese phones. And because there there are two purposes to use recognition engine for recognition and for verification. So we generate two data sets, about 7,000 character data set and 33,000 character. And this is the methods we use in the making of recognition engine. The combination is one of the best methods for recognize Chinese or Japanese now. So we apply this, we employ this method to recognize norm character. And in the classification phase, it's a cost to find methods because MPDF is a very costly, time-consuming method. So we have select candidates for it, and we improve the accuracy of the core classification by use the GLQ and KD3 to improve accuracy and to improve the speed of the recognition engine. To evaluate these methods, we use to publish a database and to our artificial database, because to, uh, to to show the accuracy of the cluster recognition, we have used a publish, and this the artificial database we know how it works. And in this slide, we will show the effects of the GLQ on two databases, G1D and G1 and 2G dataset. In the bottom, we can see that is the accuracy of the course classification, and the peak and the chart is the recognition of the file classification accuracy. And case 10, 20, 30 is the number of candidates. As the number of candidates increase, the accuracy will increase. But it's not necessary to select more than 100 or 200 candidates, because they only reach to a limit. And we can see that with the course classification of GLQ is better than the original about 2 points. And second, we can see that the engine with GLQ is better than the original. The upper curve is the reason with GLQ, and the lower is the reason of the original. And last, we can see that with 10 candidates, we can get the accuracy compared to the engine with 100 candidates. So if we just select 10 candidates, we can reduce times for calculating the file classification. And in this slide we show the effects of KD3. The blue curve is the speed and accuracy of the engine of the course classification with 10 candidates, and the green one is the speed and accuracy of the engine with 50 candidates, and the baseline is the speed and accuracy of the original. As we see, with an upraise epsilon values, we can we just reduce a little of accuracy, but we can accelerate the speed 2 times. Okay, in summary, with GLQ and KD3, the combination time is reduced about a quarter to a half, and the recognition rate keep the same. We can choose the parameters, appropriate parameter to select the appropriate engine. And about the digitization system, I will show you the demonstration. Sorry, it's not work. No. Oh no, which time? It should be VLC or not. There's only which time here, so we can play this movie. Oh, sorry. In this interface, the reason of polarization and segmentation will show. And on this interface, we can select, we can fix the reason of polarization and the segmentation. With the segmentation, we can we can use the tool to we can use mouse to change the boundary of the character, and we can draw the boundary of the character with to repair the segmentation error. And we have integrated the character recognition engine here, so we can show the recognition reason here, and we verify by manual. We can use handwriting recognition. We can write. Oh no! If you don't know Chinese or Japanese, you just draw. It's not necessary to write. Just draw. So you can fix the error of recognition and segmentation here. Okay, in conclusion, we have implement set up binary image processing and a high accuracy character recognition engine. We also develop a user interface to enable operator can verify the process reason of polarization, segmentation, and recognition. And with this works, we hope that we set a background work for another research in the future. And now, when we have a recognition engine, and we have a interface to verify, so we can verify, we can collect the patterns, and we can change this pattern, the character pattern, and we improve the recognition engine, and we do again. We have, and we made a ground truth for these documents, and there are many research and development in the future, and these are the improvements. First, now we have just segment into character. It's necessary to segment into line, text line, and we have a recognition, so we will improve with the recognition by character segmentation. And as I said, we don't have we have very few tests of this document, so we don't have we can use the bigram or trigram to fix the recognition reasons. So at the first time, we just use a dictionary to constrain the lexicon, the output, and after that, we can solve the reason I present here, and with this demo I will show on the YouTube and I will introduce my work to another and call attention to the work to the young generation of Vietnamese and for collaborative research. Now I just do by myself. And I need more people to cooperate with me, is partners. Okay. Thank you. That's all.
Any questions? In terms of program runtime, how long would it take to OCR a typical document?
Programming? Take time to program?
No. How long would it take your program to OCR a typical document?
Sorry.
How long would it take your program?
How long?
To
the runtime. Programming.
Mm-hmm.
Speak of the recognition engine.
Yeah.
Okay. Okay, I don't write here. I'm not remember, but less than one millisecond per character.
Okay.
I think
That's
so.
excellent.
Okay, it's set that about 0.15 millisecond.
Hey, if I remember correctly, I think I saw you also present this work at ICTAR in Beijing, or maybe?
No. I think
mistaken.
it's ICR.
Yeah. So, but
No?
I remember something about norm recognition, and it was like quite impressive progress. What I'm wondering is about, so in the beginning you said that there is a mix of characters which are native to GNOME, and also from the Han Chinese characters. So I was wondering also how many characters there are which are native to GNOME, and so you probably need to have like quite a large, be able to recognize quite a large number of characters which are specific to GNOME, but also the traditional Chinese, and whether there's any risk of confusion between the characters. And maybe a follow-up would be also then if the system would in principle also be applicable to Chinese OCR, or the characters from the Han that you had in the first one of the first slides.
Oh, so your question is how many characters of GNOME?
And are specific to GNOME?
Specific? Now, we hear there are about 33 characters, but not all of them is the native GNOME. It said that about GNOME and the Paro character is the Chinese is about half.
Okay.
But there's because people don't do statistics here. They just say that because they work, and as you see that in so in this tendency we can see that maybe half. So when they read some tests, they just say that's half as sit for, but it's not. There's no exactly number now.
Thank you.
You are using synthetic images in order to train your system. But we saw that for the evaluation, you're using the real images together with the ground truth, I suppose, in order to measure the accuracy of your system. The question is, why don't you, since you have ground truth for several characters, why don't you split this database to training and test set? And you are using this synthetic data.
So your question is why I don't make the ground truth and do evaluation?
But I think you already have a ground truth.
No, not yet. Not yet.
But how do you evaluate your system?
Oh, okay. the complete system, I haven't done the evaluation on the set on the complete reason of the system. Okay, in this evaluation, just about the recognition engine on the character.
Yes.
And in previous works, we have a evaluation on the segmentation. But when we develop this systems, we have not do evaluation on this, not on the recognition reason. How in this phase, how many work is recognized correctly? We haven't done yet. And in the future, of course, after I improve the recognition, and I will do ground truth. I will make ground truth this document, and then we will do evaluation later. Okay. I hope so. Thank you very much.